Hey everybody, welcome back. Today we are looking at writing chemical formulas for ionic compounds. We're also going to talk about naming them as well in this very quick tutorial. So let's go ahead and let's look at a few rules. If we are given elements and we need to come up with an ionic compound formula, a chemical formula, remember, will show you the elements that are involved in making a compound, as well as the subscripts that tell you how many atoms of those elements you actually have. So the first thing that we want to do when we're told two elements that we're going to combine as an ionic compound is we need to determine the oxidation number for each of those, which is the charge for each element. Now we're going to look at that in just a moment, but before I go through the rules, we can go ahead and look at what we would do here to determine that. Remember that these columns are going to tell you what your oxidation numbers are. So all of these metals down here in group 1 are going to always be +1 because they have one valence electron. So they're going to lose that one valence electron. They're going to gain a charge of +1. Everything in column 2 here, because they have two valence electrons, are going to lose 2 to become +2. Now these transition metals are a little bit different. They're a little bit awkward. There's a few of those that have more than one possible ion choice. And so we have to be careful with those. We have a reference sheet that kind of helps us remember. The most common ones we're going to deal with are going to be copper and iron. Iron can be iron 2 positive. It can be iron 3 positive. For copper, we can have copper 1 or copper 2 positive. So we're going to be told with a Roman numeral which one we're using. Okay, but let's go ahead and let's look at over here on the side. Everything in this column, which is column 13 or 3A, they have 3 valence electrons. So they're going to lose those 3 valence electrons to become +3. Everything that is in column 14, generally a lot of times you're going to see the elements at the top like carbon and silicon. They're going to take place in some covalent bonding, so we won't really see these a whole lot. Over here on this column, so we've got column 15 with 5 valence. This is where these elements start to gain electrons to complete their octet. So in their outer energy level, they are all trying to get to 8 electrons. Because they have 5, they're going to actually gain 3 electrons and become 3-. And then everything here in column 16 has 6 valence. They're going to gain 2 to become 2-. Everything in column 17, they have 7. And so they're going to gain 1 to become 1-. Remember, everything in the last column, these are our noble gases. They have a full outer shell already, and so they don't have an oxidation number. It's 0, essentially. I don't want to say they don't have one, but they don't have a charge because they're not gaining or losing electrons. So that was a super quick rundown of what we had learned already with regards to valence electrons and electron charge. Those charges are the numbers we are talking about when we look right here at which oxidation number and charge we're going to use for those elements. All right, after we determine those charges, we're going to be crisscrossing those charges, basically switching them and writing them as subscripts at the bottom. We don't want to include plus signs and minus signs whenever we finish these out. So you should never see plus signs and minus signs in a complete chemical formula. And then if you can simplify ionic compounds, you do so. Sometimes the charges directly cancel out. They might be the same number, like you might have a 2 positive or a 2 negative, but you might have something that has a 4 and a 2 and you cancel it out. For example, lead, you can start out with a 4 positive charge and then you can have oxygen with a 2 charge, and the 2 and the 4 can simplify. So we're going to go ahead now and look at some examples. And so let's see, I have some examples here of potassium and chlorine. We'll start with this one first. What you're going to do is use your periodic table to find potassium and chlorine. And so if we flip back to our periodic table, one of them is here and one of them is here. So I know this one's going to have a 1 negative charge, and the potassium is going to end up with a 1 positive charge because it is in column number 1. Okay, so what you do is you have your little ion charges. This guy over here is your cation, right, because it is the positive one. And then this guy over here is your anion because it's a negative one. Now these are ones. +1, -1. They cancel out. So you just, when you write your formula and you put those together, it's just KCl. As far as the bottom down here, you have potassium. And then when you go back to your periodic table, you will see that we have oxygen in column number 16. So now we're dealing with not only potassium, which is still +1, but this guy has a 2 negative charge. Okay, so what happens here? So what I'm going to do is I'm going to take those numbers and I'm going to essentially crisscross them to the bottom. And so I end up with that 2 that's now going to be written behind the K as a subscript. The 1 that's understood from the potassium is now understood to be behind the oxygen. So you just switch them. Now, when I taught freshmen to do this, some of them said it was easier for them to take these charges. And while this, I know fundamentally is incorrect, they went ahead and they just wrote the numbers down here. And then they switched them so that it was easier for them to see. So that does work as well, if you want to think of it as that. So you could always go ahead and write those numbers at the bottom and then switch them over. So that works pretty simply, okay? All right, here's another example where we have copper 2. That Roman numeral right here is really important because copper has 2 different ions, and this is telling us to use the 2 positive charge. So the Roman numeral is the charge. If you go back and look at the periodic table, our chlorine atom is over here, and so it's a 1 negative charge. And so what we end up with is this. Of course, many of these charges here, like this chlorine, is actually written, let's see if I can get my eraser. Whoop. I need to just close this out. Okay, if we grab our eraser many times, you are only going to see that. You're not going to see the 1 because, again, they're understood. So again, we take our numbers and we switch them. We crisscross them down as a subscript. So the 1 is now going to be understood to be behind the copper. The chlorine is going to have a 2 behind it. Again, if this method, and let's ignore this for just a second so I have more room to write. If this method, you know, works better for you and you want to write that 1 negative down here and now, oh, let me switch those numbers, that still kind of gets you to the same result ultimately, okay? And that's our goal. So there are 2 ways you can look at it, whatever your mind likes the best. Okay, so next up we're looking at iron 3. So again, that 3 is telling me that iron has a 3 positive charge. And then sulfur. So if you came back over here and looked at your periodic table, let's clean this up a bit. Sulfur is here. So I know it's a 2 negative charge. And if I come back over here and we write it out, now I've got some numbers to crisscross and to switch. So when I do switch them and crisscross them down, I end up with Fe2S3. And none of those numbers reduce or simplify. Let's say that I want to give you one here that simplifies just so you can see one. Let's say that we were dealing with the iron, Roman numeral 3, and then we were also combining it with nitrogen. Okay, if you did this, then you end up with a 3 positive for iron. And if you go back and look at your periodic table, nitrogen is here. It's going to actually have a 3 minus charge based on its location in the periodic table. So when you go to put these 2 together, they will actually cancel each other out. So you must simplify these types of problems, okay? So that would be the chemical formula for this compound. All right, now when you're doing naming, the rules are similar in a way. You have to first check to see if your first element is transition. The reason that we do that, guys, is because if we have a transition metal that happens to have more than 1 ion, you must use a Roman numeral. Okay, if it is transition, determine if it has more than 1 charge possible. So our most common ones we see are going to be iron and copper, but there are others. You know, you have chromium and manganese and gold. There are plenty that have multiple. You can reverse crisscross if you need to determine the charge of those compounds, or I'm sorry, of those transition metals. If you determine that one has more than 1 possible charge, do a reverse crisscross or draw atoms out to help you figure out what charge or what Roman numeral you need to use. You're always going to name the first element, the metal, like normal. Include that Roman numeral if it's transition with more than 1 charge. And then you always change the ending of the anion or the second one to IDE. So let's take a look at some examples. I'm going to go ahead and just draw these out. So let's just say, and we'll start simple. Let's say that we have Na2O. The first thing I want to teach you to do is determine if that is a transition metal. When you find sodium in the periodic table, it is one of the representative elements, an alkali metal in column 1. Therefore, I don't need to worry about determining if it has more than one charge. The only thing I have to do here is name the first one. So I would write it as sodium. And then I take the second one, which is oxygen, and I change the ending to IDE. So instead of saying oxide, and it kind of takes a little bit getting used to what the general consensus is here, but it becomes oxide. For example, if you had a phosphorus back here, if this was phosphorus instead of saying phosphoride, it's just phosphide. So there are a few of them that you kind of have to get used to seeing. Okay, if we wanted to name another one, we could have, let's see, we could have copper again, and let's just say, let me give you this one. Okay, copper and oxygen together. First thing I do is I realize this is a transition metal, and because it is a transition metal, I need to decide, does it have more than one charge? Now we have a reference sheet that we use to determine that, but we know copper does. If you check that reference sheet, you have a 1 positive and you have a 2 positive charge. Okay, you can reverse crisscross, which means take these numbers that are understood to be down here as subscripts and switch them back to the top. These are understood ones, okay? Now if I reverse crisscross these, I have a little bit of a problem, because I know that oxygen should not be a -1 here, okay? Oxygen is actually a -2. Another way that you could do this is you can say, well, I know oxygen's not a -1, I know it's a -2. That means that this one must have been a -2 if I'm trying to get that oxygen to the correct charge. But that can get a little complicated. So you could also draw atoms out to kind of help you figure out what is going on here, okay? So let's just say when we're looking at this image here and that chemical formula, we know we have 1 oxygen atom, right? And we know we have 1 copper atom. Why? Because the subscripts are 1 to 1. Well, what's the charge on this oxygen? 2 negative. Okay. I know that overall a compound must have a 0 balance, 0 charge overall. It must be balanced out by charge. Therefore, the only charge possible to do that and cancel that out would be a 2 positive, and I'm working with this ion right here. Okay, so that means when we go to actually name it, once we have identified the fact that it is 2 positive, I must actually take and use the Roman numeral 2 in that name. Okay, so I still change the ending to IDE, but the 2 is telling me that I started with the copper 2. Always go back and check your work. It cannot hurt to go, well, look, I've got a 2 positive because it's copper Roman numeral 2, and then I know oxygen's 2. Oh, look, they cancel, and that gives me CuO. If I check my work and I get something other than this, then I didn't do that correctly. So go back and check your work, okay? So that is one way you can do that, is to determine those charges. I hope you learned a little something, and good luck with this lesson.